right, so welcome. Sorry the technical difficulties. All right, so there is an attendance quiz today, but since you can't access it because Canvas is not working, then I'm going to not make it mandatory. So if you want to take that for just your own help, it is going to be called design, and then I'll take it off as being mandatory and just make it an optional one. So today I had requests to go through more Thevenin and superposition questions, so we're going to address those today. And then requests I'll take at the end for Wednesday's class, and then tailor it based on kind of what you guys would like to see more of. So Thevenin and superposition. So summary of superposition is that you're going to solve this circuit twice because you have two sources. You're going to turn one on and then the other one off, solve it to find IX, and then turn the other one on that you turned off, and then the other one off that you turned on, and then solve it for IX. Then you add those two together. So go ahead and take a minute to try to solve this for both those types of solutions. So IX when your 4 amps is on, and then IX when your 48 volts is on. So yes, I did email these lecture notes to the class today for today.
What do they do? We did compare it.
You could get $40. Oh, wait, what's the cheapest? Oh, you get it's $30 per volt networking job. For $40, you could get virtual currency and get who knows volts. I can hope some jobs
Amazon Fire.
Yeah, I can't right now. Amazon Fire.
Because there's nowhere for the
For
It's only $7.
What kind of controller do you use for an Amazon?
Yeah. Use the TV remote.
It's on the latest version too.
It's different.
Does that support clock? If that is clock, and you find out that other guys.
I got grabbed.
Did Amazon?
So that's why there's
Did they buy motion You don't have them before or
Yeah, it's because I use Amazon. I didn't realize it would show my account. Don't look at my purchases screen.
trial.
That's just a new update. Yeah, it's fun. That's just a new update.
The trial update.
You get PS5 free. You get a demo. Oh, you're in terms of comments.
Yeah, the more 50.
The one place that see, that's the thing. It's like you may shoot. I know. Is it not?
You don't think I'm gonna
Yeah, I guess we could just
like, yeah, for that function.
but like, I like fonts. What is that translate into? Microsoft. Oh, this was the public. They're doing crazy things with that one. Wait, what are you talking about? Wait, it's just because I haven't done the. I'll show you what my. There, it's like live there. My health immunization, which I should probably do.
You don't have your vaccine.
I have to do all.
You don't
I should
have your
probably.
sexual assault training. You don't have mass advising. So you don't have permission to find some
Well, I think that's just your.
You just say you're actually graduated.
No, oh, that too. No, not my high school.
It's missing that. It says ignition. If you were graduated. Bro. How are you still not transferring? We are capacity.
That's true. It's like, it's 50-50. Usually after I update if I update Windows, if I switch to Arch, it's a hardware issue. It's not, it's just finally I use Oh, I did my to do work on Friday. Shift finish. Is it shift finish? No, it's the office. I blew up the office on Friday. Because I wasn't paying attention to which channel I was changing.
sounds so weird. I was thinking cousins. Very successful. Yeah, that's probably. He's not probably.
It's a great year to be older.
You're not even a Wolverine.
Oh my god.
You're a yeah.
Yeah, that's
You lost it.
Or I think she's
Only real. I do like this.
I do like it.
Like it's in my.
No, yeah, I would only
There's no stabilizing.
I don't think you're starting in I do like it and like in person. Or in person don't. Well, I guess in person. We're gonna make Would you like me to class?
I even forgot your name. John. Oh, it was? I thought it was. No.
Because you're thinking of what?
All right, so solution of the current source open and the 48 volts on. So that means that it's gonna be an open. And if this is open, there's no current flow through here, so the same current flows through each of these. And I only have one node that's an unknown in that middle of V1. If I find V1, I notice that IX is going to be V1 over 6 plus 4 of 10. So knowing that, I can write it, I guess write it here. So IX will be V1 over 6 plus 4. And then solving for this, I just set it up. So V1 minus 0 over 5, 3 plus 2. V1 minus 48 over 2. V1 over 6 plus 4, which is 10. And then getting a common denominator of 10 in each of those gives me 8 over 10. And then 48 over 2 is 24. It goes to the other side for a positive 24. And then solving that gives me V1 gives me 30 volts for this one. So that middle node is going to be 30 volts. And then the IX for the 48 volt contribution will be 30, which is VX or V1 over the 6 plus 4 of 10. Everybody following that one? Okay. Any questions about this part of the solution? Okay, so this one is 3 amps is your value for when IX is the 48 contribution. Then for the 48 volts being ground or going to 0, that becomes a wire, and then the 4 amps. So in this one, I have 3 nodes. I call them VA, VB, VC. And then IX in this case will be VB minus VC over 6. Any questions about that description of IX? So then I have 3 equations in this case to solve for this one. So out of VA, so this is my equation 1, this will be my equation 3, and this is my equation 4. I have VA minus 0 over 2, VA minus VB over 3, and then coming in is A minus 4, or I can set that equal to 4. So that's my equation 1. Equation 2, so equation 2, I have VB over 2, and then I can either do VA minus VB over 3 and a minus of that, or equal, or I can say it's VB minus VA over 3, and then IX, which is VB minus VC over 6, and then number 3, is going to be 4 amps goes out, and then a minus VB minus VC over 6, which is a VC minus VB over 6, and then a plus VC over 4. So I don't want to do those by hand, so I went to Wolfram Alpha, and your calculators would also do this. And so I set up the equations, I checked that they were the same. I used A for VA, B for VB, and C for VC. And then I did that IX, and I called it X, was equal to VB minus VC over 6, and that gave me the 1.6 amps. All right, questions about this part of the solution? Okay, so IX with the 4 amp contribution is going to be 1.6 amps, and then we add both of those together to get the total of 4.6 amps. Everybody following that? Okay, any questions about this one? Okay, you want to try another one? Okay. All right, so superposition, how many circuits are going to have to solve for this one? 3, correct. Okay. So 1 on, the other 2 off, and then 1 on, the other 2 off, 1 on, the other 2 off. So you're going to have a contribution, and this time solve for Vx. So you're going to see a contribution from the 1 amp, from the 12 ohms, and from the 3 amp. One of them is very easy, which is nice.
You basically just shut all the other ones off. And then, like we said, more like evil logic. Yeah, you're right. That's my 5 minutes. I am. I got how do you get negative 10? That's such a huge number. Okay, I got 5 for my BS, which sounds about right. For my BA, and then my 1 and my preamp is where it starts to get really messy. It's probably my preamp. I did it all wrong, didn't I?
Maybe the current delay is. So at the very least, for your leftmost current source, sorry, I'm when short this, all your current goes through that, and this ends up being all zero.
Oh, that's all. Oh, that's all. Because there's no. I keep it that's zero. Right, because. But there's no reason to zero, so it's basically just infinity. So it's 0. Okay. That's step 1.
That's probably what you need. Okay.
That fixes everything.
So yeah, and then for the central pool, so you have a voltage difference of 10 across here, right?
Yeah.
So if you math is the total resistance of right?
Yeah.
And so you do 10 divided by 30 to the current, multiply that by 50, you get, yeah, you get 55. So, yeah, you get 20.
Okay.
And then the last one, so you get 3.
Yeah, I saw that.
So you're good. You can tell from that.
Yeah, that's nice.
So this is 20 versus 4 added.
Yeah, 20.
And this is 10. So twice as much current should be flowing through that as
I
this is 1 amp. Oh, it's 2 amps. 1 amp.
Okay.
It's 15. Because it's going negative.
Okay, so I was just making it all.
Sorry.
No, you're good.
No, I was talking.
No, you were talking to me, I know. Okay, that makes sense. I thought this stuff was crazy.
What? Next Monday.
It's just a review day. So will there be like anything new?
Nope, this is the rest of the material. just getting better at all these.
Don't those take a while to crank away so like someone's like that?
All right, so for the case where you have 1 amp on and the other 2 off, I think it's easier to see like, oh, that wire isn't parallel with the 12, so for sure there's no current going through there. What can be confusing is on the right side, you ignore the 18, you ignore the 3 because they're floating, so they have 0 amps in there too. But note, like the 15 plus 10 plus 5 is also can be combined into one resistor, again in parallel with a wire. So there will be no current flowing in that one either. So Vx for the 1 amp contribution will be 0 because there's no current flowing in that. Any questions about why that's 0? Okay. Hopefully people are seeing that. So first one, yes, question.
Decide whether it's like connected or floating, or connected or
So hopefully here, I mean, seeing that that is just, oh, I can't see that one. You know, this is literally just a dangling wire there. So that's easy to see, hopefully, that it's open, floating. Okay, so that one's easier. What's more confusing is it because it's the 15 in series with 10 in series with 5? So those are all connected, but they're connected to a wire. So they're basically like just connected together in a little circle, and there's no voltage applied to it in the circle. So it's just like you have a wire, and then like I have a resistor. It's kind of even in its own circle. So if you were to take a loop, it would be equal to 0, and then your current would be equal to 0, so voltages across those are equal to 0. Does that help? Okay. Other questions? Okay. For this one, you have the 2 sources off and the 3 amps on. So with that, you have, 3 paths, and I chose V1 as the top node, and then you doing node voltage from that. In the left branch, or the left pathway, it will be V1 over 15 plus 5. Yeah, 20, V1 over 20. And then you have V1 over 10 in the middle, and then on the right, you're setting the current in that path, so it's 3 amps throughout that whole wire. So 3 amps here and 3 amps here. So there's no change with those resistors, and then I can solve that equation for V1. And then Vx is going to be the current that flows through it, which I defined as V1 over 20. And then with the current going in that direction, it would be a negative I times R. So I have a negative V1 over 20 times R, which is 15. The other way you could do this is define the current in the same direction and say it's 0 minus V1 over the summation of those, which would be a minus V1 over 20 times 15. Does that make sense? Polarity-wise? So whichever direction you choose. If for VI, so for Ohm's law, if your voltage is equal to your current times R is in the same polarity directions, then it's plus. If not, it's that minus. So this one yields a Vx contribution for the 3 amps of a minus 15 volt. Right, questions on this one? If you got it, great. If not, questions what you did? Yes.
I used a current divider in Ohm's law and got the same answer. Is that still?
Uh-huh. I mean, this is basically doing the current division. It's just doing it using node voltage. So it's still going to be the current division. So if you identify it, you have to be careful to note, like, oh, in that branch it's just 10, and in the other one it's 20. So by inspection, if you remember the memorized equation for that one, it's good. But if you don't, then so you could say that this is IX, and IX would be 3 times the opposite branch, which is 10 over 10 plus 20. And then your Vx will be, again, a negative Ix times 15. So either way, you can achieve the same. Any other questions, comments? Okay, last one. With the 10 volt on and then the other two open, note that I called that node above 10 V2, but V2 is also equal to 10. And then looking at this to do node voltage from there, I'm going to have an unknown current, Ix here. Since I'm trying to find Vx, I then looked at Ohm's law. And I can define the current in there because I know V2 across all the resistors. So 10 over all the summation of the resistors. Again, 18 and 3 are ignored because they're floating, so they have 0 current in them. So 10 over the summation of those, which is 30, gives me my current. And then I can set my current equal to, or set it equal in the same, I didn't set it equal. It's in the same direction as Vx, polarity. So then it's a plus I times R, and that gives me 5 volts. All right, question about this solution? Okay. So summing all those together, your end answer would be that Vx is equal to a negative 10 volts. What would be another way of checking if this answer was correct? Not doing superposition. Any thoughts?
Do like nodal analysis?
So you could just do a straight nodal analysis and put it in the calculator and check, is it right? So just one nodal analysis instead of the 3 steps. All right, questions on this? All right, you guys ready to move to Thevenin? Okay, so for Thevenin, you want to find the equivalent circuit between this location A and B. And so you're going to find the voltage there as VTH, and then find the equivalent resistance from A back to B for RTH. Take a minute to solve for that one. I thought it looked very similar.
I know Finnegan. I wish I had this list. Like it's literally only for professors.
I'm gonna just suck in. So what section?
Sorry, oh well. Because there was something Ryan the Beanie, and I was like, that's not Ryan, I know who it is. But he was able to find
Yeah, the
it.
one next to him, sorry. Okay. All right, so for this one, you need to find VTH and RTH. So VTH, I just copied the circuit and then I set my ground. Oops, this is not right. I just realized I did not do that right. So VTH is going to be, I don't have my value for VX. Anybody solve this to get VX at that location? I'm going to do that quickly. So 4 is equal to x over 4, x over 6, and then x minus 2 over 3. And there's no current going through the 2.5 ohms. All right. Wrong. Okay, so 6.22 volts. So knowing that Vx is 6.22 volts, Vx is, or VTH is Vx minus, note that this node is 2 volts here. So VTH is Vx minus 2. So that gives me the 4.22 volts. Okay. Questions on that? Copy this over quickly. All right, any questions about that one? Yes.
Why is it
So VTH is, so with this no current going through the 2.5, then it's at this node, which is all Vx. And VTH is between there and then right above the 2 volt source. So you can either do it's Vx minus the current going through the 3 ohm times 3 ohm, and that current would be Vx minus 2 over 3. Or you could say, I know that that voltage right there at that node is going to be 2 volts because of where the battery is in comparison to ground. So you see that the node at B is 2 volts? Okay. So I can then just say, well, Vx is in between those two, so it'd be Vx minus 2. The other way would be to say VTH equals Vx minus I times 3, and I can be defined as Vx minus 2 over 3. And that would yield the same number. So whichever way you like to look at that one. So remember a voltage difference where the VTH is, that means where the plus is, I'm measuring that voltage and comparing it to what the negative is. So I'm going to take that plus and subtract off the negative. So for example, if there was a 10 volt battery at Vx and a 2 volt battery at VB, the difference between 10 volts and 2 volts would be 10 minus 2, so there's an 8 volt difference between those two locations. Does that make sense? Usually that's easier to see with batteries there. So it's the same concept, just in a circuit description.
Is it always, I guess if it's 0 current, then still enthusiastic.
So yeah, there's zero, you understand that there's 0 current there because it's open. And so if there's no current, there's no voltage drop across there. So whatever is at the node before it is the same as the node, basically through that resistor, which is all A. Does that make sense? Other questions? Okay, for the Thevenin resistance, your pathway goes through the 2.5 ohm, and then it splits. It goes 3, 6, and 4. So you have 3 different pathways, then they converge at the bottom. So 4 is in parallel with 6, is in parallel with 3. Give you a second to look at that. The other way you can do it is highlighting with the colors and saying like, yeah, that does visually see it with blue on the top, green on the bottom, and those 3 would then be in parallel with each other. All right, questions about this equivalent resistance? Okay. All right, last one. On this one, RL equal to 0.4 ohms is your load. So remember with the Thevenin, you're going to take off the load to find the Thevenin between A and B. So basically remove this first. And then find the equivalent resistance between A and B. Okay. right, so with this one, setting up the equations for VTH is going to be between A and B. So I did V1, V2, and V3 nodes. V1 equation is 1 plus V1 minus V2 over 3 plus V1 minus V3 over 2. And then at V2 location, the V1 minus V3 over 2 comes in, and then 1 amp goes out, and V3 over 3 goes out. And then at 3, you have 1 coming in, V1 minus V2 over 3 comes in, and then V2 over 4 goes out, and V2 minus 2 over 2. And that gives a V2 of 1.14 volts, which is equal to VTH. And then for RTH, you have 4 in parallel with 4 in parallel with the 3 plus 2 plus 3 in series for 1.6. All right, requests for Wednesday types of problems. Anybody have any requests? So more Thevenin and superposition, yes. Designing op-amp circuits, okay. Any other requests? Yes. Which one? Thevenin, more Thevenin. Saying lots of, okay, so Thevenin for sure, a superposition, and then designing the op-amps. All right, see you guys on Wednesday.